All right, matrices. So a little bit about the terminology for a matrix. They actually define matrix for you right here in your book. It's a rectangular array of variables or constants in horizontal rows and vertical columns. This is just a way to display information. And so we have rows and columns, and they kind of tell you what those are. Right here, your rows go this way. Columns, think about columns on a house. Columns go up and down, right? Columns. So this particular matrix has 3 rows and 4 columns, all right? Element. Each value in the matrix is called an element. So each one of these is a specific element, all right? The element is depicted by what row and what column it is in, all right? What row and what column it is in. So you have this element here, this -1. That is in row 2, column 1. Row 2, column 1. So it would be depicted by so this little capital letter is your matrix, all right? So if they want to tell you that they want you to look at this particular element, they're going to say a little a, lowercase a, 2, 1. All right, that's not 21. That's actually telling you row, column, okay? And so A21 here, A21 is going to say row 2, column 1, that's this guy right here. All right? And so they give you another example, -8. -8, that is in row 3, column 2. All right? So row 3, column 2. So you have row 1, row 2, row 3, and then the second term in that row. All right? So that's how you depict it. The other thing that you have here are dimensions. Dimensions is how you describe the size of the matrix, all right? M rows and N columns is what they say. So you list your rows and your columns. So if I were to ask you the dimensions of this particular one, you would actually tell me the dimensions here is a 3x4 matrix, 3x4. 3 rows by 4 columns, 3x4, all right? So let's look at example 1 here. Example 1 in the middle of the page. It says, answer the following questions about this particular matrix. The first thing they want us to do is state the dimensions. So the dimensions of this are just going to be my rows by my columns. How many rows does it have? 2. And how many columns does it have? So this would be a 2x3. Easy enough. All right. Now it says, find the value for A13. So we have to go to which row and which column? Row 1, that's this. Which column? 3. So what is the element that's in row 1, column 3? -18. There we go. Questions on just the terminology of matrices. All right, so let's try some special cases here. Special cases. You'll notice for this row matrix, it's called a row matrix. Why do you think it's called a row matrix? There's only one row, right? Multiple columns, but there's only one row, so it's called a row matrix. So then, on the other hand, we have a column matrix because it only has one column. Square matrix. Why do you think it's called a square matrix? Yeah, it's a 2x2, 3x3. The dimensions are the same, rows and columns. And then we have a zero matrix. You don't see this a ton. We're going to do this when we do like multiplication and all. You also have something called equal matrices. Equal means that every single element is equal to the corresponding element. So this element in row 1, column 1 is equal to the element in row 1, column 1. Those are equivalent. Those are equal. Those are equal matrices. All right, adding and subtracting matrices. To add or subtract matrices, they have to have the same dimensions, all right? Because the way that you add and subtract is you simply add the corresponding elements, all right? If they don't have the same exact dimensions, you will not have a corresponding element to add it to. So if I'm adding, I'm literally going to take A and add it to E, and that's going to be my first element. B added to F, that's going to be my second element, and so on and so forth. Same thing with subtraction. A minus E, that's my first element. So you're either adding or subtracting your corresponding elements. I will say, this is not hard. The biggest problem I see here is basic positive and negative numbers, messing them up, like adding, subtracting positive and negative numbers. So that's like the biggest problem I've seen here, but it's not hard. So let's look at these examples. All right, example 2. Find each of the following for, and they've given us 3 matrices here. They want A plus B, and they have written it out for us. All right, they want us to add A plus B, so we're going to take the A matrix and we're going to add it to the B matrix. All right, and so A plus B is going to equal 8 plus 12. That's my first element. 3 plus negative 7. That's my second. Negative 5 plus 6. And 14 plus negative 23. All right, easy enough. Simplify it. 8 and 12 give me what?
20.
3 and negative 7.
4.
Negative 4. Negative 5 and 6.
4.
And 14 and negative 23. There we go. All right. That's literally all you do. Let's look at B. B wants me to say B minus C. What is the problem here? Yeah, so if I were to start doing this, I would say 12 minus 2, negative 7 minus what? There's nothing there. And so this one cannot be done. You can't subtract them, so you would have no solution here. There's no way to do this. It is, yep, no solution. You can't do it. All right. Scalar multiplication. Scalar multiplication is very simple. It is like distribution. All right, so think about distribution with a parentheses and a number on the outside. You simply multiply everything on the inside by the number on the outside. That is scalar multiplication. This is also used when you do enlargements and stuff like that for geometry figures. But for this one, take the 3 on the outside, multiply it by everything on the inside, and you are done with this one. So you're just going to say 3 times negative 6. Yep, 3 times negative 3. 3 and 7. 3 and 10. Yep, what's next? And then what? There we go. All right. Very simple. Same thing with the negative 4. Just pay attention to your negatives. You're going to distribute through to all of those. So your answer on these should be the same exact dimensions of the one that you started with. All right. So your answer on these will be the same exact dimensions. So addition, subtraction, and multiplication. And by the way, division actually works similar. You would just multiply by the reciprocal. So if I was dividing this by 4, that's the same thing. You just divide every piece by 4 because division is just multiplication by the reciprocal. So it works the same. If you were to divide a matrix, you just divide everything by it. All right, let's try some. 1, 11, and 19 on page 27. State the dimensions. They want you to add 2 of those, and then they want you to do a scalar multiplication. So for any matrices, these hold true. Commutative property, you can add, subtract in any order. It does not matter. Associative property, because it's all addition, you can group them however you want. Scalar multiplication, it doesn't matter which side of the matrix the number is on. It is multiplication. You can do it either direction. You can also do equations with matrices. All right. So multi-step operations. You treat these just like you would order of operations. So you either need to distribute the 4 through to both of them, or you need to add them first and multiply by 4 at the end. Okay, so those same rules that you would think of with order of operations apply to matrices. And so for this one, you would need to add the two matrices first and then multiply by your 4. All right, so you would want to add these. And then after you do that, you're going to do your 4. If not, you're going to have to distribute through, which I think is harder. So if you add first, you're going to get something like this, hopefully. All right, and then you're going to distribute your 4 through. All right, so basic order of operations apply. The last thing we're going to do is we're going to solve equations. So capital letters mean matrices, all right? Capital letters means that they're solving for a matrix as your answer. So we have 4 and then a capital X minus a capital B equals a capital A. That means all of those capital letters are matrices. We know A and we know B, we're solving for X, all right? So this is just like algebra equations, but with matrices, all right? And so you're going to put it in there just like that. You would say 4, X we don't know, minus B. And so we're actually going to insert B right there where the B was. And then we're going to say equals A. And we're going to insert the matrix A here. And so if you had this algebra equation, how would you solve it? What would you do to solve for X? Yeah, I'm going to have to add this piece over because I want to get rid of it on this side. And I need to add it to both sides. So I'm going to add it here. And I'm going to also add it here, all right? And just like in regular algebra, on the left-hand side here, they all cancel. I have one matrix that's minus and the same exact matrix that's plus. Those are all going to be zeros. So that zeroes out. Since I added it to the left side, I need to add it to the right side. And so over here on the left, I just have that 4x. And on the right, I'm adding these. So I'm going to say -9 plus 5, and I'm going to do that with this entire matrix here. All right, and so you're going to add those. And then what do I need to do to solve for my x? What's my next step? Yeah, divide by what? 4. Divide by that 4, all right? Oh, let me scoot this guy up. Oh, there we go. All right, so divide by that 4. And when you divide, it's the same thing as multiplying everything by the reciprocal. So you're literally just dividing everything in there by 4, all right? So my final matrix is going to be all of these divided by 4. -4 divided by 4. 8 divided by 4. 12 divided by 4. And so we're going to do all of this. And that would be my answer. I would have an entire matrix as my answer. And you could check it. You could literally plug that back in and do order of operations. Multiply by 4, subtract that matrix, it should equal what's on the other side. All right, so you can do it just like you would do an algebra problem. You're simply solving for a variable, but in this case, your variable is a set of numbers. It is a matrix. All right, let's try a couple. The first one is just order of operations. You're literally just plugging in the D and the E and solving. And the 31, you're solving for a matrix.